Hi, this is King of Review. In this problem, we want to solve the system of linear equations by using Cramer's rule. So if we have two linear equations in the form ax plus by equals e and cx plus dy equals f, then we can use Cramer's rule to solve the system, that is, find x and y. So Cramer's rule is a method where we use determinants to solve a system of linear equations. Cramer's rule states that x is equal to the determinant of the x matrix divided by the determinant of the coefficient matrix. And y is equal to the determinant of the y matrix divided by the determinant of the coefficient matrix. So let's set up our matrices. Let's start with the coefficient matrix. So the coefficient matrix, the entries for this will be the coefficients of our x and y terms. So we have A, B, C, and D. The x matrix, well, this is going to start with E and F. And you know over here that E and F are the constants. And then we have B and D. And the y matrix, this is equal to AC, EF. So this is how we set up the matrices. So let's fill these out using our values. Let's start with the coefficient matrix. What are the coefficients in our system here? Well, we have -2, -6, 1, and -7. -2, -6, 1, and -7. And now the x matrix. Again, we start with E and F, and those are the constants. So -6 and -7. And then B and D, which are -6 and -7. And then for the y matrix, we have A and C, -2 and 1, and E and F, -6 and -7. So now we've set up our three matrices, but you notice when we use Cramer's rule to find x and y, we need to use the determinants of these matrices. So what is a determinant? Well, a determinant is a real number that's associated with a square matrix. Let's say we have the matrix with the entries A, B, C, and D. To find the determinant, we're going to take the product of the entries in the main diagonal, AD, and then subtract the product of the entries in the other diagonal, CB. So AD minus CB, this is how we find the determinant. So let's do that for our matrices. We're going to start here with the product of the entries in the main diagonal, so -2 and -7, and then subtract the product of the entries in the other diagonal, 1 and -6. And when we work this out, we get 20. So 20 is the determinant of our coefficient matrix. Now let's look at our x matrix. We're going to take the product of the entries in the main diagonal, so -6 times -7, and then subtract the product of the entries in the other diagonal, -7 times -6. And this works out to 0. And then for y, we'll take the product of the entries in the main diagonal, so -2 times -7, and subtract the product of the entries in the other diagonal, 1 and -6. And when we work this out, we get 20. So x is equal to the determinant of the x matrix. We solved for that here, that's 0, over the determinant of the coefficient matrix, that's 20. 0 divided by 20, that's 0. So we know that x is equal to 0. And for y, we have the determinant of the y matrix, that's 20, divided by the determinant of the coefficient matrix, that's 20. 20 divided by 20, well, that equals 1. So we have y is equal to 1. So we've solved the system here. X is 0 and y is 1. So letter D is correct. Thanks for watching.